it is important to synchronize threads or clients, threads that handle clients in a server, because these threads may be modifying data in a database or in some file, and without synchronization they risk to overwrite each other's modification. There are multiple mechanisms of achieving synchronization, and many of them are studied in operating system classes. Here we are going to go for POSIX threads over mutexes. Mutex stands for mutual exclusion and refers to an area of code where a single thread may be present at a time. It's called a mutually exclusive area. If a sequence of instructions looks like this way over here, mutex, it's an area where we are guaranteed that only one thread can be present, can be executing an instruction in this area. While executing instruction in an area, a thread may observe that it's lacking some conditions that can only be specified by or provided by a different thread. In that situation, the thread can exit the mutex area waiting on a condition variable. As soon as other threads provide the condition that this thread was waiting on, it can be signaled to get out of its conditional variable and to continue its execution. While the thread is waiting for these conditions, other threads may be able to to execute. In order to enter a mutual exclusion area, a thread will call pthread mutex lock whenever the set of instruction is finished. That's signaled with a pthread mutex unlock. Between these two, a single thread may be executing at a given time, except if some threads are waiting on the pthread, on the condition variable. In order to wait on a condition variable, a thread has to call the function pthread condition time wait. And typically a timeout can be provided, after which the thread will return back to execution. In order to wake up a thread that's waiting on a condition, one can call the function pthread condition signal. If multiple threads are waiting on the variable, one can call pthread condition broadcast, which would wake up all the threads waiting there, rather than one by one as performed by pthread condition signal. But only one of the threads will be able to enter back in the mutual exclusion area at a time. It is safe to call the signal function from outside the mutex in C. If a thread is calling signal from inside the mutual exclusion area, that thread will have to first exit the area before other threads can get inside. But nevertheless, signals could not be generated from a signal handler, since this could lead to deadlocks. The mutual exclusion areas implement Dijkstra's PV concept, which stands from Dutch proberen en verheugen, which is test, signal, and raise a barrier to let others that test the barrier to enter. With a condition, they implement the whole monitors. In order to access these mechanisms from POSIX threads, we can use the definition of a condition variable using the type which can be declared with pthread condition type. And the mutual exclusion area is declared with pthread mutex. One can initialize the MP variable by assigning it with pthread mutex initializer, or alternatively, it can be initialized by a function pthread mutex init. The condition variable can be initialized with pthread condition init. As we have seen before, in order to enter the mutual exclusion, a thread has to call pthread mutex lock and to exit with pthread mutex unlock. While inside the mutual exclusion area, a condition can be tested. If the condition is false, then a timeout can be computed and stored in the timeout variable of the type struct t. And the pthread condition time wait can be called with the condition variables, the mutex region and the timeout, to test whether the condition was satisfied or just the timeout happened. We can test the result. I recommend you to perform as exercise writing of a program with two threads that together compute a Fibonacci series, like standard one, f0 equals f1 equals 1, and fn plus 2 is fn plus 1 for every subsequent n. And you can do this having one thread computing the even values and another thread computing the odd values. You would have to synchronize to tell each thread when the values before it were computed. You can implement this in either C or Java. Hint, you can use 3 mutexes, and for this one you would not need condition variables. The whole monitors are an implementation using a mutual exclusion area and multiple conditions. Threads that enter the mutual exclusion can wait on the conditions, while other threads inside the mutual exclusion area are able to wake up the threads that are waiting on the conditions as soon as the conditions are satisfied. Next, we are going to be discussing about C++ threads.